Some ideas in physics are just so profound they're almost impossible to picture. Take the idea that at the tiniest subatomic level, space and time are actually the same thing. How do you even begin to imagine that? Well, what if you could? Today, we're diving into an incredible vision for how to turn that exact concept into a stunning cinematic experience.
Right? It's a huge question. We're not talking about just another documentary with some animations. The challenge here is to make the truly invisible visible. To create a film that doesn't just tell you about quantum relativity, but actually lets you experience it. So here's our roadmap. We'll start with the core mission behind this whole idea. Then we'll see how the film would actually show the universe forming out of pure chaos. After that, we'll meet the actors, the particles, and learn the rules that govern their incredible dance. And finally, we'll get into the nitty-gritty of the filmmaking techniques that would bring this hidden world to life.
Okay, let's dive in. First up, the vision. The ambition here is way bigger than just making a cool movie. It's about opening a window into the fundamental fabric of reality itself.
This is the mission statement, and it's a big one. It's all about taking two of the heaviest hitters in physics, quantum mechanics and relativity, and showing how they finally connect at the smallest scales you can possibly imagine. It's nothing less than an epic scientific quest, visualized.
Yeah, this goes way beyond just animating a textbook diagram. The real goal is to use the powerful language of cinema, things like light, shadow, movement, to let you feel that moment where space and time become one. It's about building an intuition for a concept our brains just aren't wired to grasp on their own.
So how would this whole vision actually play out on screen? Well, the proposed film would open with a truly stunning sequence, the birth of space-time itself.
Imagine starting in absolute chaos. Space-time isn't this smooth, continuous sheet we know. Instead, it's just a sea of shimmering, disconnected fragments, like the tiniest possible pixels of reality. And as the camera dives right into it, we get to witness this incredible transformation. These chaotic pieces start to self-organize, locking together into a perfect, coherent grid. We're literally watching our ordered universe emerge from pure randomness.
All right, so the stage is set. Our universe is born. But what about the actors? This is where the vision gets really, really creative, completely reimagining the fundamental particles that make up this quantum world. We're all used to thinking of particles as little billiard balls, right? Tiny dots zipping through space. Well, this vision reimagines them as something way more beautiful and, frankly, way more weird. They're geometric waves that aren't just traveling through space-time, they are literally woven into its very fabric. Now, to guide this incredibly complex dance, a visual signpost shows up, something called a unit quantum vector. You can think of it like an arrow that's constantly showing the direction and probability of the system's next move. It's kind of like the conductor of a quantum orchestra, showing us that this bizarre world isn't just random, it's following a deep, hidden logic. And speaking of logic, let's talk about the rules of this universe. How does the film actually visualize the fundamental laws of physics that are pulling all the strings behind the scenes? You've probably heard of the Schrödinger equation. I know it sounds intimidating, but the film treats it like the story's script. It's the ultimate rulebook that every single particle has to follow. But instead of just flashing the formula on screen, the film would visually solve it, letting us watch in real time as the quantum system evolves exactly as the physics says it should. And here's where relativity makes its grand entrance, and things get really mind-bending. In this cinematic world, time isn't a rigid clock ticking away, it's a flexible, dynamic field. The film would actually visualize time subtly bending and warping based on what's happening at the quantum level. It's a stunning glimpse of how truly malleable reality is at its very core. So, we've got the story, we've got the science. But the big question is, how do you make it all feel real? This last section is all about the specific filmmaking choices designed to make sure this is seen as authoritative science, not just science fiction. Every technical choice here is deliberate. 8K resolution isn't just for a bigger TV. It's so you can see every microscopic detail with breathtaking clarity. A 24 frames per second rate isn't an accident. It gives the whole thing a deliberate, weighty, cinematic feel. The purpose of every single choice is to create this authoritative, mysterious tone, to make you feel like you're watching a real scientific probe, not a cartoon. And you'd see that serious tone in everything. We're talking advanced visual effects like volumetric lighting and ray tracing to create a true sense of realism and depth. The camera moves are slow and deliberate, smooth orbital shots and long, slow zooms that feel like a scientific probe exploring a new frontier. Even the educational bits, like equations, are seamlessly integrated so they feel like data popping up on your instruments, not text from a book. And this part is absolutely crucial for maintaining the film's credibility. There's a clear rule: no fantasy, no over-the-top sci-fi effects. The whole point is to ground the viewer in a feeling of authentic discovery. The sense of wonder here doesn't come from made-up stuff, it comes from the profound reality of the science itself. So what this vision really gives us is a powerful blueprint. It shows how the language of cinema, light, motion, composition, can be a legitimate tool for exploring and explaining science. It really makes you wonder, from the inside of a living cell to the heart of a black hole, what other invisible worlds are just waiting for their close-up?